Right, it looks like we're back. I'm just testing the live stream here. And okay, let's go to the live stream here and see if it works. Hit refresh. Right, we are live. Just going live here as well. Yep, and the little test that did come up. So also I'm just going to do a share. So copy this link and I'll just do a quick share. Maybe I should start using Instagram and share there. Wonder if anyone actually cares for that. If you care for sharing on Instagram. So I'll actually do the share. I'll just click on it on the Twitter thing. I'm going to share this link on Twitter just so that people can join if they want. And I might do a couple of shares during the course of the... So just going to hit post straight away. I think we do the regular decent share. Right. So we have posted. I'll hit one refresh to see if it looks a bit nicer on the post. Click on that. Okay, so we're live. I'll probably do a reshare at some point in time. You can put comments in here. People can put comments in here, and I'm not going to be talking about this book, which is my book, although I might come back to it at some point. I opened a couple of links because I tried to start doing the live cast before, and the comments weren't available, so users can't put comments in. Anyone who is actually joins the live stream can't put comments in, but now you can put comments in, so that's quite good. And I was kind of like, what I was actually doing was I was looking through these Python books, and I've picked one of the books, which is called Module of the Week. And if I click on a link, it launches it up over here. So I'll close that tab, and I'm just going to. This is kind of like an overview, but I'm just going to kind of like go through everything pretty much that's available here. It's got some interesting stuff, but one of the things that I did want to do quickly was, if I pull out and I just wanted to look at some of the code, and because I was talking about this before I restarted the stream. Yeah, some of this is just scripting code. Everything that's given in loads of these books, and that's actually included. That's actually why I pulled my book up. That's given in a lot of the books. It comes as stuff like scripts, basically, which is fine. And Python's a great scripting language. That's outside of JavaScript. Probably the best scripting language, and it might even be the best, including JavaScript. But actually, what we like to do is put things into classes, functions, modules, because we want to compartmentalize the code and repeat it and use it. Just hit back. And one of the bad habits that I see a lot, and I did actually see this in this particular book somewhere, was the use of the wildcards, which was really annoying, but I kind of wanted to click or find one of those bits that did have it. But now I can't find it, so we'll look at other stuff, and if we come across it, then we'll come across it. I think decimal, floating point math. No, it wasn't in there. So, mathematical functions. Might be something about the iteration stuff, actually. Just I don't want to go through that as an example, because I actually did a recent video on it. Iter tools. Could have been one of these. Yes, it is. So we just don't do this. right, which is from ittertools import star. We just don't use the wildcard import. Like, it's considered to be poor practice, and the reason why is it clutters up the namespace. So we do see this all over the place in examples, and the reason why is because you just want to import everything and just demonstrate the module. So whoever's built, the ittertools module or whatever, and you want to demonstrate it in a small script, it's perfectly fine. So the wildcard, yeah, that works fine. It's very convenient. Now you've exposed all the methods and attributes and everything that was available in that module. Now, what is the ittertool functions here? Well, this one I'm presuming is an ittertool function, is slice. And this one here is an ittertool function, which is t. And in fact, I could sort of like go to it. I'll copy all of this and I will paste it in my VS Code. So if I just go over here and if I hide that, the VS Code comes up, which is quite good. And I just paste this into VS Code like this, and let's have a look. I'll get rid of all of the stuff on the side here, so we don't need to see that, and then do plus plus. Right. This was written in Python 2.7. How do I know that? Well, I can see that this is not inside brackets. So brackets fixes that problem. It's the biggest spot of errors, or not errors, but Python 2 versus Python 3. But importantly here, we've got from ittertools import star. And I guess, I don't know, if I start typing things, some of these are probably ittertool functions and not like our global functions, our name in our global namespace. And really the way to do this is to import ittertools as, we'll just call it ITT, there we go, that's unambiguous. And if I comment this out now, straight away we see the things, and I presume that this is now an it dot slice, right? Here we go. And is that an it dot count? And this is the thing about it. If I was using this, I would never know, because count looks like a user built-in function or something like that. Or I could have made my own function, and quite commonly I might not make an is slice, but I might make a count function. I probably won't make a t function, but this way of doing it now exposes or keeps the namespaces concise. So everything from the ittertools module is now preceded with this alias. You don't have to use this alias, this as it. I could have used the whole ittertools, but if I did use the whole ittertools, it'd be quite clunky, ittertools.t. So we understand that it's it, but at least we've now compartmentalized the namespacing. So just wanted to bring that up. Everywhere that we see this from thing, we just are not using it ever. And I don't actually know what this does. So I'm going to hit clear over here. I might even, well, I'll keep it in the terminal. I could run it in interactive Python, which runs things over on the right hand side. But let's just hit F5 and see what we get on that. What's it actually going to do anyway? Oh, well, anyway, it's done it. So R equals it dot is slice it dot count. Okay, so it's just counting up to 5. It's taking slices. An interesting one. I'm actually going to go and look at the description here, just because, well, it works. It's doing something that's sequential, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and so forth, and then it's going through I1s and I2s. We can hover over it and see what these functions do. This is just taking a slice, and the first argument that goes into this slice, this is slice, is an iterable. which is the it.count. So that's our iterable. We'll go and inspect what it is. And our second one is the starting position, interestingly. Because it doesn't have a stopping position. But maybe that's fine. But it doesn't look like it starts from 5. That's the interesting part of it. But let's just go to this it.count. Returns a count object whose next method returns consecutive values. So it just counts from naught and a number of steps. Let's just go over here. Returns a tuple of n independent iterators. Okay. And then for I in I1, k, we've got I1, and we get I2 over here. I still don't get what that function does. So let's just jump back to the actual code. So get our window back here and now have a little look at this. Right, and it tells us anyway. I was actually going into more about the having a little whinge about the wildcard. This was the first one, but here the T function returns several independent iterators. It defaults to 2. So unless we put in a value here, we did put in a value in our code, funnily enough, didn't we? Okay. It has it has semantics similar to the Unix T utility, which repeats the values it reads from its input and writes them to a named file. Okay, standard output. Okay. Sometimes these things are done well by example. I can effectively see what it's doing because it's doing all of the I1s from 0 to 4. And it's doing all of the I2s from 0 to 4. But I'm wondering if I could have achieved this in a different way or if it's got advantages or something. But let's go on to this anyway because it's a good module to actually. I was just going to jump into a random module. So this is a good module to jump into because the ititools module is actually extremely powerful. It does all of these combinations and permutations and things like that. All these iteration types of stuff. The functions, in fact, I should just read it rather than saying what it is. But the functions provided are inspired by similar features of the lazy functional programming language Haskell and SML. They are intended to be fast and use memory efficiently, but also to be hooked together. And that was actually part of the when I did hover over it in the VS Code. It was part of the next thing, which means that it doesn't store all of the data in some sort of array. That's what this lazy piece is referring to. It doesn't mean that people that code in this language are lazy. What it means is it doesn't occupy a lot of memory. Just remembers the value that it's on, and then jumps to the next one, does the next one, and forgets that all of the previous ones in memory. So that's why they're fast and memory efficient. But also hooked together to express more complicated iteration-based algorithms. Iterator-based code may be preferred over code which uses lists for several reasons. Since data is not produced from the iterator until it is needed, all the data is stored. All of that data is not stored. Importantly, not stored uh, in memory at the same time. Reducing memory usage can reduce swapping and other side effects of large data sets and increasing performance. So we're not going to see again when we've got like these small lists, but when we have some kind of massive list, we're going to start getting decent advantages, I guess. So a quick sip of water for me as a reward for reading one paragraph. And I might do a repost as well just to make sure, because now that the stream is actually working, could do a repost. But let's get back to this, the chain function. Okay, so it's going to go through a lot of the functions now. Some interesting ones, some not interesting ones. remember, each time that we have this star, we're not going to do star. We're going to do. I wonder if I can write over the top of this. I probably can't. But we're always going to do on our version. We're going to go and do this import itchain, and we are going to use the alias, and I've just aliased it as, I don't know, I don't even know why I called it ITT. It should be maybe ITL or something like that, or ITS. But we're going to use this alias so that our namespace is condensed. And if I did go back and copy some of that code here again, and I'm going to have to amend that print statement, no doubt, because it's going to have to be in brackets, and I'm going to have to precede this now with chain. And again, chain is something that you might just named one of your local functions, and then you'd have you'd have ambiguity as to which function you were actually using. As in, if I made this function def chain, right, because I wanted to do something else, right, and then print hello, right, I've now, like, which chain is actually being used? Is it, if I wasn't, if I was just doing from itchain import star, am I using the itchain chain, or am I using my function chain? And I believe it's the last one that's written, but you've just created this ambiguity and you've accidentally overwritten something. And the thing about this is, if we look at itchain and all of these modules, right, it's like scrolling up, we can see that there's tons of functions. Actually, it's not as big, it's not as important, should I say, on itchain as it is on other ones. Like NumPy's literally got like 100 different like methods and attributes and classes and stuff. But here it's still pretty decent. Like cycle, count comes up loads of times, right? In other modules. So imagine you had like 2, 3, 4 modules, uh, all imported with aliases. You like the count function that cropped up in that. Well, it's probably in pandas. Um, the count function that cropped up is just going to be whichever was the last imported module, I presume, is going to be the one that's overwritten it. Now, some things like filter false you're not going to have, but like group by, that one is definitely a pandas module. So if I did have, we look for group by, but import pandas, right? I won't do the as PD yet, just to show you that you don't need to alias, but can pandas dot, and then I wonder if the group by is here. No, that's a grouper. Um, so not with a group by, which is fine, pandas, but we can put an aliasing here, PD, just to show that we could do either or. So PD dot group, it's got grouper as well, so not group by. Maybe it's a data frame, df equals pd dot data frame, and then dots. I wonder. Yeah, there we go. There is a group by there, so I wasn't going mental. But the point is I think the group by in itchain was still actually a class, and this one's a function, and so this one's got a lowercase and the other one had an uppercase, so there still wouldn't be a naming collision, but we were close to a naming collision. So I nearly got a naming collision off the top of my head. But anyway, we're just going to avoid that at all points in time. We're going to always just import our things, and if it's a long name, we're going to do an aliasing to shorten it. And if it's something like import math, there's probably no need to alias math because it's only 4 characters anyway. So it's really for the ones that are a mouthful, where we kind of like feel that we need to use the aliasing because we're too lazy to type the real code. So let's just go back again and put that window capture back on so we can see it and jump to it. So the chain function takes several iterators as arguments and returns a single iterator that produces the contents of all of them as though they came from a single sequence. So, okay, chain takes several iterators as arguments and returns a single iterator that produces the contents of all of them. Right. So, this does find chain, I guess, you know, I think we can just add lists, and that's what this chain function looks like. So that's an interesting one. So I could jump back straight to the code, and yeah, I probably wouldn't, like, some of these things I just wouldn't think to use because they are actually covered, and maybe they're covered in the later versions of so like Python anyway. Um, Maybe this is actually more efficient. I'm not even sure. But if I go here, I presume we've got our chain thing working, right? So I'll comment this one out because I didn't even know what this is. Slices. Or, I'm sure that it's got uses, and I'm going to remove this chain thing here. And now we're just going to do find it. But actually, what we're going to do is instead we're just going to test out what this it chain is. So let's just do result. This is quite a common thing that I do, equals, and then I'm going to take all of this it chain, right? Because this might just be one value because it might be an iterator, because that's the whole point of iter-tools. And I think we might have to do a for loop kind of like on everything to expose everything because it's going to do the next. But if we just do print result, oh, I wonder if we get a memory address coming back or something. I just printed return result. There we go. Yeah, here chain, it returns a chain object. It says it there in the actual text, and it returns a chain object whose .next method returns the next element of the first iterable. So presumably we could keep doing a .next on it. But if I just do an F5 print result, I wonder what we get. We get the first item on the chain. No, we get the object. There we go. So print result dot next. I think we have to put the next like that. I wonder what happens there if I do that. Yeah, get a 1. I wonder if I run. No, I won't get it. Okay, it'll start at 1 again. So I do it again. Okay, but we could do this because I've seen this somewhere else. There we go. Now it's going to do the first 3, I guess. There we go, and then it does A. So it does 1, 2, 3, and then A. So what this actually does is if we have a list 1, list underscore 1, O1 equals, and then 1, 2, and 3. Notice that nice spacing in the thing. That's the nice clean convention. And then I'm going to steal this because I can't be bothered to put the quotations around every single character. But list underscore 2 equals, and then ABC. This would then be list 1 here, and this here would be list. This is actually quite useful now that I'm typing it because we're still going to get the same thing, but we get this iterable, and if I remove all of these print nexts, so / them out and just do print and then do result, remember that we get this memory address, right? This nice efficient thing. So like there's this object, chain object, and it's at this memory location. So we could print an ID of it, it'll be somewhere like in print ID of result. It exists somewhere. It's going to be given some unique number, the identity of the object. There we go. That's its Python identity, been given a place somewhere in memory. Interestingly, I wonder if we always get the same place in memories and it just doesn't never change, it just iterates the same spot in memory. So that's an interesting question to ask. I'll comment this out for now. But how do we get the size of something? So I think it's from the sys module. Import sys. And then do sys.size. No, it's not. What I wanted to do, this would be quite a good demonstration. I keep forgetting these things. I am actually going to I'm opening up Google Claude. It's in the background because I'm doing this off the laptop. So, but how do I get the size of an object in Python? See what it gives me back because I can copy that straight into the code. How do I get the size of an object in Python? Oh, is sys and then get size of. Why did it not work then? Okay, let's have a look. I'll try that again. It was a sys module, and then sys.get size. I probably just didn't look down the list enough. I could have typed in size maybe. By the way, the other nice thing about, well, I won't alias here, but about doing the import this way, because no point aliasing sys to sys or sys to s or something like that. But the one nice thing about doing it this way is that when we do the dot, it exposes everything. So we can see an entire list of stuff. Now get size of is at the top of it. So there we go. But anyway, if I do get size of and then result, like this, and I'd have to print it out. So print all of that. And then I'll do something like, because it'll get confusing after a while, the size of the iter is colon. There we go. So this is a little bit cleaner. But if I run this now, we get this size and it's size 48. Now the demonstrations that everyone does is if I make this bigger and bigger and bigger, the size won't change because it's an iterable. Whereas I can join up two lists, right? So I can do joined list is equal to, and I believe I can just do list 01. I think I can get away with this. List 02. This is what we tend to do because we're quite lazy. So that's me. And then do print joined list. Okay. And I can print a list. Hopefully, I'm just testing that this works. And there we go, get the whole list. And I could do for I in joined list. So I could repeat this pattern. So this is why you might ask a question. I did on the other thing, like what's the advantage of this? But take a look at this, right? For I in joined list, right? I'll print it on the next line. Print I, right? So instead of printing joined list now, comment this one out. We do the for loop on it and hit F5. And we get that same pattern, we get the same result. 1, 2, 3, 4, A, B, C. And we might ask the question now, right? Well, what's the advantage? You know, if I expose this one here, and I'll call this the print, just so it's not ambiguous again, the quotations, iter tools for loop, right? That's our itchain for loop. And this one here, the next one, is our, we'll just call it our list, our standard list for loop, and run them both. So F5. I've probably got other things in between, but let's have a little perusal of it. Our standard list for loop gave us 1, 2, 3 ABC, and somewhere, wherever it was, how about printing it out? That would be very helpful. There we go. Uncomment that, and now kind of let's just comment this away. I could leave. This is just going to be a memory address. I know actually it won't because I'm going to iterate through it. We'll just see what that is anyway. F5. I'm interested to see what comes out of that. I will get something in between our loops. I was going to remove the clutter, but we get our 1, 2, 3 ABC, and then from our earlier one from our itchain loop over here, from our itchain loop, we also get 1, 2, 3 ABC. So we get 1, 2, 3 ABC from our standard list loop, and we get it from our itchain loop. And the question is there's our little bit in the middle. That's what I was wondering if it would actually give us our latest thing, but it doesn't. It gives us the object, right? I wanted to keep this bit in because it's the object is still size 48. But I guess already that we've got a handle on this, which is we can do a print of the get sys dot get size of, and then our object, which is the joined list, right? Each item in a joined list is going to be small. So, in fact, each item is going to be they're going to be roughly the same size, but not completely, because it's actually a joined list of integers and strings actually occupy more memory space, I believe. I can actually show that each integer, right? Because the integers are going to be, the first three, so I can pick any one of them, like element naught, first index of the list, and each string, pick the last one because it's unambiguously the last one. So we can use negative indexing, -1. There we go. And I could have picked element 6, right? Or not 6, 5. Be careful because then -1 because it goes from 0 to 5. Nearly made the classic mistake of coding, which is that the indexing in a list is 0, 1, 2, 3, 4, 5. So the last element, even though this is 6 long, the first element is 0 and the last element is 5. We have to learn how to count in mathematics. Counting in mathematics should start at 0, but we use our fingers. We start at 1. So humans count badly because our first number is 0. Computers count well. So that's each string, but then I wanted to also do print. I think you're going to get the hint of this already. The list. Now, I'm just going to jump over here just to make sure that I'm just checking if anyone's put any comments. There's no comments that I can see. Hi, send. I'm just checking to see if anything, because I don't actually see the chat. Top chat. Let me see. Live chat. Okay. Put another hi in there. Okay, I do see the comments now. I've got to make sure that I can see if anyone has joined, which is very unlikely because I've only posted it and I don't have that many followers. Please follow me. No, please don't follow me. Let's just go have a look there. Yeah, that's fine. I might actually, while I'm here, just share this again. I'll like retweet it out for the sake of it. I don't know why. hashtag Python and a hashtag Python programming. And there's a live YouTube thing there, so I'll hit return. YouTube live stream. There we go. Close that out and hit close there and get back to the code. So just checking that we're on it. Yeah, we got the code there, that's fine. So the last bit was this list, which I'm going to print out the whole list, join list, right? We're going to get the size of the whole list and run it all. And we get you can kind of like already begin to see this, but we get here from our itertools loop, we get the 1, 2, 3 ABC, and we get the size of it is 48. In our standard loop, we've got 1, 2, 3 ABC, and each integer is smaller. So the itertools has actually cost us. That's what we think. And each string is 50. But look now, the list starts growing. And actually, if we made the list a little bit longer, so I'm just going to have to, I wonder if I should, if we make this list a little bit longer, so for example, I'm now going to do 4, 5, 6, 7, 8, 9. I wonder if I made it long enough. There we go. If not, then I will do another little trick, but we'll run it again. The important bit to look at now is nothing really changes. This is 28. Look at this, each string is 28. Ah, yeah, okay, fine. I have to use negative indexing now. Be careful of that, because item number 5 is no longer. I'm going to do negative indexing to guarantee that I've got a letter at the end, right? So each strings, we know that strings are longer than integers, so they were never the same size. So we don't know, I'm telling you that, or at least we observe that strings are longer. There we go, each string is 50. But we see that this size has grown because it's 152. If I can go back 2 of them now, because it was 152 on the earlier one, which was the same one, but it's grown from 104. So even by doing this small grow, we can see that it's grown a lot. Now, we can make this grow a lot because we can do list comprehension, x for x in range 100, right? I don't know if we want to print all of these things out, but I guess we're going to. But it doesn't matter because our end bit is going to be this joined list. And now this is 100 long. F5 to run it. There we go. Jumped up to 880. So although each integer is 24 and each string is 50, the list now has grown to 880 in memory in terms of memory size. And if I do scroll up, I wonder if I can find it. Our iterator is still at a pretty cute 48, right? So that's quite nice. That's something that we want to do. If we want to join lists and we want to join them in an efficient way, because if the lists are large, we should probably step away from doing our lazy bit of Python. People say Python is slow. Well, it is. If you do it this way, it's slow. Python is slow this way. There's loads of ways of doing this, by the way, like NumPy. Create 2 arrays and kind of like join the arrays in a more efficient, compact way than doing lists. But we tend to use lists quite a lot. So I always end up talking about lists in Python. It's like the most convenient object ever. So we sacrifice convenience for speed. But the fact is because computers are so much faster than us, and because some of our code doesn't use very large lists, it's okay. We sort of like we'll live with the fact that it's a bit slower. Um, I have something that runs in perpetuity in the cloud, and it does hundreds of transactions or whatever. But like the latency of the internet connection is way longer than if I was to go through a list of like 10 items. So it's more case if you're doing powerful stuff, then you wouldn't do this kind of practice. But anyway, let's just jump back then. So we jump back to the actual book. That was quite a nice little feature. So that was a nice little read through, and I should actually just remind myself of the piece that we were doing there, which was, scroll right to the top, chain. it was this bit here. Chain joins two lists together, but it joins them together in an iterative type of way, okay? In an iterative way. So let's just continue then in that case to our next function. Let's just see what else we've got. So I'll make that screen again and jump back. So we go from chain, and the next one is izip. Izip returns an iterator that combines elements of several iterators into tuples. Okay, it's going to do the same type of thing, and it's going to have the same type of efficiency, which is that I could actually just do this, so why not? Copy that and go straight back to the code. I probably won't do any more of those just because I think we're going to get the hint. I'm not going to do this to list 100 anymore. In fact, maybe 5. 3. Make it, I don't want to make it too long, right? We paste that in here. Remember that we've got to do an it dot this. That exposes the izip method if izip is available. I think it is because we can see that it dot izip, right? Nope, doesn't come out. I wonder why did that not anyway, I'm going to print an I. It dot I don't think that this is going to work because I'm not sure that izip's available. Because when I do this dot thing and do I get an I slice, but I don't get an izip. So we'll run it. I expect a big red bar to come across it. Maybe it's changed over the years. Yeah, it does. Again, like we can see that this non-aliasing, or sorry, this avoiding the wildcard meant that we could call the actual ititools module. We call the ititools module using the alias it right at the top, not this wildcard. And immediately when I did the dot afterwards, it exposed all of the methods, and I could see that that didn't come up. So I knew that I was going to get this error message, right? Exception occurred, attribute error, module ititools has no attribute. izip, this doesn't exist anymore. It's been removed. It's been changed. So izip no longer exists. We have to remember that. I'll hit stop on that because it's going to fail, right? Try. Oh, I should have remembered the error. Except. Right. Print. Can't do, can not do this. And print out the error. There we go. We've now handled the error. It can't do it. In fact, the correct way of error handling is, I should actually just put it out there again. It doesn't matter. We'll leave it. We just basically tried to do this and it failed because we knew it failed because it doesn't exist, right? Now we've got the sort of like the error message that comes out here, but there was an actual error that came with it, and we could actually handle it. So I'm going to do it because it's annoying me not doing it. I'll take this outside of the try except block and create the actual error. And then oops, got to remove the tabs. The tabs in Python are like, the indentation in Python is useful because it's clean but annoying because when you copy and paste and stuff, you have to deal with the tabs. Fortunately, VS Code deals with it quite nicely. I think other editors do as well. But if it didn't, it's just annoying because you have to move all of the spaces. But anyway, I'm going to run through this. We're going to handle our exception properly. Right, there we go. Attribute error. That's what I was looking for. So, stop. I'm told that the way of handling errors properly is in Python is that because now we know what we're looking for. We've got an attribute error. Um, this attribute doesn't exist. Itchain doesn't contain this particular attribute. So when we run it now, we get the same error message, but we've just handled it a bit better because it's literally caught this particular error. And if there was another error, we could handle all of the different errors. So, if there was a generic error that wasn't that, we could do except exception as a different type of error, right? And print, we got a different error. That's our error handling. So that's the way Python handles errors. It's quite nice actually if you get used to it. To be fair, this is kind of like the first time I've done it in a live coding session. I don't know why. I actually always use this, um, apart from very rare occasions when I have used this. Like in bigger code, proper big code, I have used this because I want to make sure that because the exceptions can come from different places. So, or the errors can come from different places, and this is kind of like a cat. This exception here is just a catch-all, and you want to really be specific, like as in the file didn't open, so that's a file error of some kind. So this one here, well, this one here, I would actually handle it just with an exception because I'm not an attribute error. I know that this doesn't exist, so I kind of like manufactured it and just demonstrated my manufacturing. But actually, like I know that this just wouldn't work. So I wouldn't need either of these errors. I wouldn't even handle for the errors. So whatever. That's just in there. It's good. So we've got that. So let's go back anyway. Oh, let's get to the bit. We've got the izip. Oh yeah, izip didn't work. But if it did work, what it would have done was do the tuples. Now it didn't work probably because it's legacy and izip was something else apparently. When I did it, well, that's not true because that's just islice. Islice returns an iterator whose next method returns the values of an iterable. Skip all previous. Okay, fine. I'm not even sure. Let's just read through. Now, some of these won't exist because the author of this, he's written a great book, by the way. I'm sure it's a great book. It looks quite good. Very, very complete. But the author of the book wrote this. It was last edited 3 years ago, and tons of stuff changes in Python over the course of time, like literally tons of it. So let's just go back. And so this function unfortunately didn't work, but there is zip in Python. I wonder actually, I can't remember if zip returns, I think zip returns a whole list, whereas what izip is returning this iterable list. But maybe there is an izip now already in like standard Python. So, but that's fine. Funnily enough, the next thing that was on the agenda was this the is slice. So the is slice function returns an iterator, so remember that an iterator is just something that um, it's part of a list, but it's each item of the list sequentially. It's not the whole list. So it's each element sequentially in the list. That's what this iterator is. So it returns an iterator which returns selected items from the input iterator by index. It takes the same arguments as the slice operator for lists. Okay, fine. So we know what slice does in Python. We can slice a list. So this is slice. Slice is a list, but actually puts it into an iterable. So that's quite cute. Quite like that. That's really useful. I might start using some of these. I haven't used tools for a long, long time, and therefore I've been missing out on somewhat efficient code. I wonder if, because it's done a count here, and again, this is annoying because I know that this is an itertools count, right? We know that it's this because we know that this thing here, this wildcard, has exposed all the methods and attributes of itertools. So we've got this slice, but actually this is not a Python function. I keep thinking it's a Python function because count looks like, just a standard, like what might be a Python function, but it's not a Python function. But what I might do is I want to sort of like compare it to the list because I think that's a better example, or the list slice. So I'm going to nick. There's not much of this that I can actually nick, to be fair. This is a it's just got a start, stop, and an index. I'm just going to take this top one, right, and sort of like go over to our VS Code again. So just going to unhighlight that. So we got our VS Code exposed, and go down here, and remember that we have to use it dot slice, and I'm not going to do this count thing anymore, right? Because I just want to, if I do the open brackets, so it's annoying. There we go. Tells me what it's iterable. I can use one of the lists actually. List 01, there's an iterable. So that's a bit cleaner actually, because we know what list 01 is. List 01 was this thing here, like 0, 1, and 2 is what list 1 was. So over here, then our next bit is our stop. Okay, we're going to have to make list 01 a little bit longer. And if we do make list 01 a little bit longer, 10, 20, right? I'm going to comment all of these out so we don't get a bunch of things printing that we don't want. So force slash these out. Go away, go away. Our joined lists. We can sort of like keep our joined list in there for whatever reason. In fact, I might make the joined list iterable because it's a bit longer. We can get rid of all of the sizes over there. And we can get rid of our try statements over here. So now we're just left with this slice. Now, just correct this as well. It needs brackets for our print statements in Python version 3. We're on version 3.10 on here, and the latest version is 3.11. Because I'm on my laptop, I'm on 3.10, but on the PC it's 3.11. And we want a stop. So our list now is 20 items long, but we're going to stop after 7 items. Just make it sort of like a random odd number, and we can sort of like print it, and we're going to get each number all the way out. So 0, 1, 2, 3, 4, 5, and 6. And I wonder if I should continue on that. We can do, so this is our iterable. This is where we stop. And we can actually have a start and a stop. So I wonder if we do start. No, okay, so let's just do it like this then. 2, comma. That was our start. Now I'll stop. 8. 2 to 8. And we won't put a step in yet. So it behaves in a certain way, and F5 to run it. And we go from 2 to 7, because remember it's exclusive, so 8 doesn't count, so we get the 7th item. And I think I'll stop the cast here, just because my nephews have woken up. if you do like this, if you found this interesting, because I might continue this. This is quite interesting. If you find this useful, then so like thumbs up, like, follow, whatever. But I'm just going through this because I'm going to read the like a lot of the book because it's sort of like a good reminder for many things. And yeah, thumbs up and like and follow and leave comments, and we'll go from there. So I'm actually going to stop the stream because it's breakfast time, and